Welcome to the Deep Dive. Today, we're tackling something I think a lot of you deal with. It's just the chaos of disorganized data.
Oh, yeah. It's everywhere.
Picture this, right? You're trying to build something, maybe analyze something, but your info is just scattered. PDFs over here, JSON data from APIs, maybe a ton of web pages you bookmarked.
And you know the answer's in there somewhere, but finding it, synthesizing it, it just feels like wading through mud.
Exactly. That feeling of wasted time, or worse, making a bad call because you missed something crucial. We've all been there, I think.
Definitely. It's like having this potential gold mine, but you've got no map, no pickaxe, just piles of rock. And that delay, that friction, it really costs you.
Totally. So our mission today is to give you a powerful tool for this. We're going to dig into LlamaIndex. It's open source, and it basically acts like your smart data organizer.
Think of it as the thing that helps you finally map out that gold mine. It brings all those scattered pieces together, makes them make sense, especially if you want to use them with, large language models.
Yeah. Right. So the goal here is to really understand how LlamaIndex can take that data mess and turn it into something, organized and actually insightful.
Okay, so the very first step, logically, is getting all that diverse data into LlamaIndex in the first place.
Right. Where do we start?
That's where data connectors come in. You can kind of think of them as different doorways into LlamaIndex, each one built for a specific type of data source.
Okay, different doors. Like what kinds are we talking about?
Well, first off, you've got all those files probably sitting on your hard drive, right?
Yeah.
PDFs, Word docs, maybe spreadsheets, text files.
The usual suspects.
Exactly. For those, you have file connectors. They're sort of the bread and butter for pulling in your local document library, just hoovering up those files.
Okay, that handles the static stuff. But what about live data? Stuff changing all the time online.
Yeah, good point. For that, you've got API connectors. These are designed to grab structured data, usually that JSON format you get from web APIs.
And APIs can be flaky sometimes, right?
Oh, absolutely. So good connectors will have built-in ways to handle errors from maybe the network drops or the API sends back something weird. It's about getting that dynamic data reliably.
Can you, paint a picture? How would that work for, say, weather data?
Sure. Let's imagine you need the current weather in London. You might use the Open Weather Map API. In Python, you'd basically use a library to make a web request to their specific address, their endpoint.
Like a URL?
Exactly, like https://api.openweathermap.org data 2.5 weather.q London and Applet key. You send that request off.
And hope it works.
Right. You add some error checking, naturally. Then the API sends back the weather info, probably as JSON. The key part is using something like LlamaIndex's API data connector to take that JSON response and load it in. It understands that structure.
Gotcha. So it translates the API's language. What about just grabbing stuff from websites like articles or blogs?
Yep, there are tools for web scraping within LlamaIndex too. These let you fetch content directly from web pages.
But you have to be careful with that, right? Ethical scraping.
Absolutely critical, yeah. You need to respect the website's rules, like their robots.txt file. Maybe rotate your user agents so you don't look like a bot hammering their site. And definitely pause between requests. Be a good internet citizen.
Okay, so we've used connectors, maybe scraped a bit, and now the data is inside LlamaIndex. But it's still just a big pile, isn't it? How do we find anything?
Ah, you've hit the nail on the head. Ingestion is step 1, but making it useful is step 2.
That's where indexes come in.
Indexes, like in the back of a book.
Kind of like that, but much smarter. An index is LlamaIndex's way of organizing all that ingested data so you can retrieve information quickly and efficiently. It's the filing system. Without it, you're just searching through everything, which is slow.
Okay, so what kind of filing systems does LlamaIndex offer? Are there different types?
Yes, several key types, each suited for different jobs. The simplest is probably the list index. Imagine just stacking your documents one after the other. It's good if the order matters, like in a conversation transcript, or if you need to go through everything sequentially. Makes sense. Simple stack. What if order doesn't matter, and I want to find stuff based on, the topic or meaning?
Perfect segue. That's where the vector store index is really powerful. This uses something called embeddings.
Embeddings. Sound fancy.
They're basically numerical representations like secret codes that capture the semantic meaning of your text. Not just the words, but the concepts.
Okay.
So LlamaIndex turns your documents into these number vectors. When you search, you can ask a question in your own words, and it finds documents whose vectors are mathematically similar, even if they don't use the exact same keywords.
Whoa, so it understands what I mean, not just what I type.
Exactly. It's searching by concept, by semantic similarity. Huge difference.
That's cool. What else is in the indexing toolbox?
Well, for data that has a clear structure, like, say, a legal contract with sections and subsections, or nested JSON data, there's the tree index. It organizes data hierarchically like a tree.
Okay, for nested stuff.
Then you have the keyword table index. This one is more traditional. It finds important keywords in your documents and builds a table mapping those keywords back to where they appear. Great for when you know the exact term you need. Precise lookups.
Right, like searching for a specific product name or something.
Precisely. And finally, sometimes you need a mix. That's where the composable index comes in. It lets you combine different strategies. Maybe use vector search for general meaning and keyword search for specific terms. Very flexible.
Okay, lots of ways to organize. So data's indexed intelligently. Now, how do we actually ask it questions? How do we get answers out?
Right. That's the job of the query engines. If the indexes are the organized library shelves, the query engines are the smart librarians who know how to find exactly what you need based on your question.
Different librarians for different tasks, I assume.
You got it. There are several types. The most basic is the simple index query engine. It basically just looks through the index using the keywords from your query. It's fast, but pretty literal.
Needs exact matches.
Pretty much, yeah. Then you have the vector store query engine. This one uses the power of those embeddings we talked about with the vector store index.
The semantic search one.
Exactly. It understands the context and intent behind your question, finding relevant stuff even if the wording is different. Much more sophisticated.
So it's better at understanding, tell me about financial performance, even if the text says revenue growth.
Precisely. It connects those concepts. And often, the best results come from hybrid engines. These combine vector search and keyword search.
Best of both worlds.
Kind of, yeah. It leverages the semantic understanding and the precision of keywords. You can often get more accurate, relevant results. And what's also cool is you can customize how these engines rank results.
How so?
Well, say you're analyzing financial documents. You could tell the engine to give a higher score, like boost results that contain terms like revenue or EBITDA or whatever matters most to you, fine-tuning the search.
That sounds really useful for specific domains. Can we see a quick example of how a query engine actually works with an index? Just the basic idea.
Sure. Imagine you've loaded some documents. Maybe one says, the CEO mentioned strong revenue growth in the latest earnings call. You'd first create an index, let's say a vector store index, from that document.
Okay, index created.
Then you'd initialize a query engine, maybe a simple index query engine for this example, pointing it at that index you just made.
Got it.
And then you just use the engine's query method, like engine.query. Summarize the key takeaway about financial performance. The engine uses the index to find the relevant part and gives you back an answer.
Simple enough conceptually. Okay, so we've retrieved information, but raw text isn't always what we need, right? Especially if we want to feed it into an LLM or put it in a report. We need summaries, specific formats.
Absolutely. Finding the info is only part of the battle. Shaping it is next. That's where output modules and response synthesizers come in.
Okay, what do?
They take the raw retrieved information from the query engine and, well, synthesize a useful response. They can generate summaries, pull out key bullet points, or even combine information from several different retrieved chunks into one coherent answer.
Cleaning it up.
Exactly. And if you need something very specific, like, say, an outline for a PowerPoint slide deck, or maybe structured JSON output to feed into another system, you can use custom formatters to define exactly how you want that output to look. It's about getting the information in the form you need it immediately useful.
Making it plug and play almost.
Yeah.
Now, you mentioned LLMs earlier. Feeding this retrieved context into a large language model seems like a key use case.
Yeah.
How does LlamaIndex help there? We have to worry about input limits, tokens, right?
A huge consideration. Yeah, token management is critical. LLMs have limits on how much text they can process at once, their context window.
Right. You can't just dump a whole book in.
Exactly. LlamaIndex helps primarily through the chunk size setting during indexing. When you create, say, a vector store index, you tell it how big each chunk of text should be.
Breaking the documents down.
Right. Into manageable pieces. Find the right chunk size is key. Too small, you might lose context. Too big, you might exceed the LLM's limit or send irrelevant stuff. You want to give the LLM focused, relevant snippets.
Okay, so we retrieve relevant chunks. How do we actually construct the prompt for the LLM using that information?
LlamaIndex makes that integration pretty smooth, often falling under prompt engineering. You basically retrieve the relevant context using a query engine.
Like we just discussed.
Yep. And then you dynamically insert that retrieved text into your prompt template before sending it to the LLM. You might use Python's f-strings, for example.
Can you give me a sense of what that prompt might look like?
Sure. Let's say you queried for competitive advantages and got some relevant text back in a variable called retrieved context.
Sure.
Your prompt could be something like F, based on the following information. And retrieved context explain the company's key competitive advantages concisely.
Ah, I see. So you're literally pasting the retrieve bits right into the instructions for the LLM.
Exactly. You're giving the LLM the specific ground truth it needs from your documents to answer the question accurately.
This all sounds incredibly powerful for building real applications. If someone's thinking about using LlamaIndex in like a production environment, not just experimenting, what are the key things they need to nail down?
Good question. Moving from prototype to production needs discipline. First, I'd strongly recommend a modular architecture,
Needing.
meaning break your application into logical pieces. Separate code for data ingestion, for indexing, for querying. It makes everything cleaner, easier to test, maintain, and scale later on. Don't just mash it all together.
Okay, modularity. What else?
Configuration management is huge. Use environment variables or config files for settings like API endpoints, file paths, chunk sizes, and critically, never hard code API keys or passwords in your code. Never commit them to Git.
Right, Security 101. Keep secrets secret.
Absolutely. Tools exist for managing secrets properly. Also, testing and logging. You need solid tests, unit tests for the individual modules, integration tests to make sure they all work together correctly.
Catch bugs early.
Yep, and good logging. Use structured logs, maybe include request IDs, so if something goes wrong in production, you can actually trace what happened and debug it effectively. Don't just print random messages.
Makes sense. Debugging without logs is painful. Anything else for production?
Yeah, security and deployment itself. Think about how you'll run it. Containerization with Docker is very common, packages everything up nicely. Maybe look at serverless options for scaling and cost. And, again, secure those API keys properly, perhaps using something like HashiCorp Vault or your cloud provider's secret manager.
Lots to consider for robustness.
Yeah.
Okay, this is great theory. To really make it concrete, could we walk through building a super simple app, like a basic Q&A system?
Let's do it. A quick hands-on conceptual walkthrough. Step one is always environment setup.
Getting your tools ready.
Exactly. You'd create a virtual environment standard Python practice, maybe using Python 3, -meter, NV, LlamaIndex, and then activating it. Then you'd install the necessary libraries.
Like LlamaIndex itself.
Right, pip install LlamaIndex core. And if we want a simple web API, maybe FastAPI and Unicorn. So pip install FastAPI Unicorn.
Okay, environment's prepped. Step 2.
Step 2, load your data. Let's say we have a simple text file, sample.txt, in a data folder. You'd use a connector, like file data connector.
The one for local files?
Yep. Something like fdc file data connector data sample.txt and then docs fdc.load data. Now your text is loaded as LlamaIndex documents.
Easy enough. Data's loaded. Now what?
Step 3, create indexes. We need to organize that data. Let's create maybe 2 types for demonstration. A simple list index.
The sequential one.
List index.from documents docs, and also a vector store index for semantic search.
Okay.
So Willia is vector store index.font documents docs, chunk size 512. Notice we're setting a chunk size there, breaking the text into 512 token pieces for the vector index.
Got it. Indexes are built. Time to ask questions.
That's step 4, query. We'll set up a query engine. Let's use the vector store index we just made. So initialize a simple index query engine, maybe like simple index query engine, maybe like
Pointing the engine at the index.
exactly. Then ask away, print, engine.query, explain the main benefits.
Yep.
It'll search the index and print the result.
Cool. And the final piece to make it a real usable app.
Step 5, API exposure. Make it accessible over the web. Using FastAPI, it's surprisingly simple. You'd import FastAPI, create an app instance.
A fast API.
Right. Then define an endpoint, maybe a POST endpoint at Q. This function would take a query string as input.
From the user request.
Yep. And inside that function, it just calls engine.query and returns the result. That's basically it for a minimal API.
Wow. Okay. So just a few lines of fast API code wraps our LlamaIndex engine into a web service.
Pretty much. It shows how you can quickly build on top of these core LlamaIndex concepts.
That really does simplify things. Thinking bigger picture now, beyond these simple examples, are companies actually seeing real, like measurable benefits from using LlamaIndex?
Oh, absolutely. The impact can be pretty dramatic. We're seeing it used across different industries to finally tap into all that unstructured data they've been sitting on.
Any specific examples come to mind?
Yeah, there's a case study of a fintech company. They were spending a ton of time preparing SEC filings, pulling info from all sorts of documents. They used LlamaIndex to streamline that whole
What was
process.
the result?
They cut the preparation time by something like 70%. 70. Think about the labor cost savings there. It's a direct impact on the bottom line just by organizing and querying their data more effectively.
70% is huge. That's not just incremental improvement. Did they share any performance details, like how fast or reliable it was?
They did. They reported query latency, how fast it answered questions consistently under 200 milliseconds, which is really fast for this kind of complex retrieval.
Definitely responsive enough for users.
Yeah. And they also achieved 99.9% uptime for the system. So it's fast and reliable enough for their critical business processes. It shows this stuff is ready for prime time.
Those are impressive numbers. It really underscores the practical value. So for listeners who are thinking, okay, I want to try this or maybe even get involved, what are the best next steps?
Well, the best way to learn is usually just to dive in, right? Start experimenting, install it, try loading some of your own data, build a simple
Get
index.
your hands dirty.
Exactly. And the LlamaIndex community is really active and helpful. It's all open source on GitHub. You can check out the code, star the project if you like it, maybe even fork it and play around.
Contributions welcome, I assume.
Oh, yeah, absolutely. They also have a big Discord server. That's a great place to ask questions, get help, see what other people are building, and just connect with the developers and other users.
Good resources. Anything specific to keep an eye on for the future of LlamaIndex?
Well, the field is moving fast. They're always adding new features. Things like more sophisticated hybrid search techniques are likely coming, better integrations, maybe more tutorials on deployment strategies like using containers effectively. It's worth keeping tabs on their updates.
Definitely sounds like a project to watch. Okay, this has been incredibly insightful. Just to kind of wrap things up, we've really seen how LlamaIndex tackles that messy data problem head on,
Yeah, from getting data in with connectors,
to intelligently structuring it with different kinds of indexes,
using powerful query engines to find what you need,
refining the output, managing tokens for LLMs.
and following those best practices for solid production deployment.
Right. It feels like it really puts the power back in your hands,
Yeah.
letting you take control of all that scattered information.
It really does. It's about turning data chaos into actual knowledge you can use.
So maybe a final thought for everyone listening. Think about your own data headaches. Where are things fragmented? Where are you losing time? How could applying some of these LlamaIndex techniques, ingestion, indexing, querying, maybe unlock new insights or just make your life easier?
Yeah, what could you discover or build if you could actually leverage all that information effectively? It's worth exploring LlamaIndex further to see how it might fit your specific challenges.